We're going to be going over the questions on the Unit 1 test that you've already taken so that you can do test corrections. Test corrections need to be done step by step, showing the answer that you gave. Work through the problem again, showing the steps. If there are no steps to be worked out, you'll have to write incomplete sentences how to get to the correct answer. You can't just put the correct answer. That's not going to get you any points. But you have to explain why you got the answer wrong and why the new answer that you're choosing is correct, because we're going to be going over each of these questions. You'll have the correct answers, so you need to show an explanation or show your work. We're going to start with question number 1. For the function f of x equals 7x minus 2, we want to find f of 2. Alright, so this is not f of x, this is f of 2. So 2 is our input, also known as our x. So in this equation, we're going to replace x with 2. So I'm going to write it as y equal 7 times 2 minus 2. Now 7 times 2 is 14, and then 14 minus 2 is 12. So y equals 12, and your answer is here. For question number 2, which function does not have the set of all real numbers as its domain? So on the coordinate plane, the domain is your x values. Okay, what that means is domain is also, it's your x, it's also your input. So are there any numbers that we cannot put into a function and get out a real answer? Now we know if we input any number here, this is a linear equation, y equals mx plus b. We do have an output for every real input. We also have y equals, we'll distribute this 10, and this becomes 10x minus 70. This is still a linear equation. Change f of x to y. So we still have a linear equation. So this has all real numbers as its domain. This last one, we have a fraction and division by 0, meaning if we have any fraction, let's just put 1 at the top and 0 at the bottom. This is undefined. So this is where we'll have a restriction in our domain. So let's figure out what that restriction is. If you graph it, you'll see that there's a break at x minus 3 equals 0, because we cannot have division by 0. So that's why I'm setting this equal to 0. So add 3 to both sides, and 3 cancels here. Bring down the x. X is equal to 3. So we can input all numbers, all real numbers, except for x equals 3. All right, question number 3, we have this table, and it's a relation that we're going to call g. We want to know if g is a function. The definition of a function is for every input x, we have one unique output. So let's look at our x's. -9, -1, 5, and 5 has 2 outputs, 5 and 7. So this is not, relation g is not a function. So let me mark through the ones that says relation g is a function. So we're left with two choices, the last two. Now we're going to look at the inverse of relation g. So we need to switch our x's and our y's. You can write it as a relation this way and switch your x's and y's with a mapping, or you can write it as a T-chart, or you can write it as a horizontal table, like here. Doesn't matter. We just need to switch our x's and our y's. So our x's were originally -9, -1, 5, and 5. So let me write it here, -9, -1, 5, and 5. And let's write our x's in place of our y's. So we're going to take our y's. -9 matches with 1. Switch the place of the x and y's. 3 goes with -1. And 5 goes with 5. And 5 goes with 7. Now let's look at our x's. We have 1, 3, 5, and 7. And each of those has one unique mapping. So we're looking at the x's mapping only to one number. So this is a function. It's not a one-to-one function, but it is a function. All right, so the second part of this is the inverse is a function. The original relation is not a function. Okay, question number 4. Which is the equation of the axis of symmetry? Now you had this equation in your hints, also in your notes. And the equation for the axis of symmetry is -b over 2a is equal to x. All right, a is the coefficient of the squared term. I don't see a number in front of the x squared, but there's always a coefficient. The coefficient is 1. How many of the x squareds do we have? We have 1. B is the coefficient of the linear term. The linear term is the x term, and the coefficient is -8. So let's put a -8 for B, and C is our constant. Constant is -7. Now we don't need C, we just need A and B. So let's substitute in -8 for B. So we have -8 over 2 times A, and A is 1. Simplify that. 2 negatives make a positive. So we have +8 over 2 times 1 is 2. 8 divided by 2 is 4. So x is equal to 4. Now remember, this equation is going to be a vertical line, so it's going to be x equals to 4, not y equals to 4. Okay, if you graph that on a coordinate plane where x is 4, we're just going to draw a vertical line through that. That's going to be our axis of symmetry. If it were y equal to 4, it would be a horizontal line this way. So that's why we don't have y equals 4 as our answer. Question number 5. For which function is the value of the y-intercept the smallest? For the y-intercept, we're going to set x equal to 0 and find y. So in our table, we're just going to circle when x is 0, y is 3. So the y-intercept is at 0, 3. We're looking at the y value. Okay, so we're going to start with 3. Then we're going to go over to this table. When x is 0, y is 2. So right now, this is the smallest value. The x-intercept is going to be at 0. I'm sorry, the y-intercept is going to be at 0, 2. Previously, it was at 0, 3. So this one right here is the smallest intercept. Now here we don't have a table, but we can replace x with 0. So 0 minus 15 is -15. So that point would be when x is 0, y is -15. So 0, -15 is going to be way down here. So right now, this is our smallest value. And then lastly, 7 to the 0 power, anything to the 0 power is 1. Okay, so that would be 0, 1 up here. So the smallest value is going to be absolute value of x minus 15. That would give us 0, -15. Negative numbers are always smaller than positive numbers. All right, question number 6. In which interval is f of x always positive? All right, now some of you got tricked on this one because on our review we talked about negative, okay, but we want to know where they're always positive. The hard bracket includes -5. So at -5 is everything above the x-axis, because this is x equals 0, the x-axis. All right, is everything above, okay, at -5 to 0? Well, not here, because at -4, okay, this is on the x-axis. It's neither positive nor negative. Okay, so it's not going to be this one. We can include -5, but we can't go all the way to include all the numbers to 0, because here and also here, 0 is neutral. 0 is not part of our positive numbers. All right, let's look at the interval from -2. Right here, we can already say at -2, it's not including -2. So that might be okay, because the soft bracket means it's open. We're not including -2. We're just starting at -2 and going to 0. So -2 to 0, we don't have any numbers above. Those are positive. All of our numbers on this line are below the x-axis. So that's where y is, that's where f of x or y is negative. All right, now we're going to go from 0, so we're going to include 0. I can already see at 0, our numbers are on our line are below the x-axis, so that's out. Let's see if this last one works. From 1, not including 1, that soft bracket, that open bracket says not including 1, but going over to 2, do we have values above the x-axis? Yes, so these are positive. That's the only interval on the x where the y values are positive. All right, find the inverse of f of x equals 4x minus 2. So we're going to set f of x equal to y, and then we're going to switch the x and y variables. So y becomes x equal 4y minus 2, and then we're going to solve for y. So the first step is to add 2 to both sides. We cannot add 2 to the variable x. We just have to write it as x plus 2. Bring down your equal sign. Keep these two sides separate. Okay, on the right hand side we have 4y, and then 2, -2 plus +2 is 0. We're not going to write that 0 here. That's going to disappear. It's invisible. All right, all we're left with around the y, and we're undoing all of the operations around the y. So we're using reverse order of operations. We're going to divide by 4 on both sides, and I'll go ahead and distribute that 4 to both terms. And then x divided by 4, let's pull that x out to the front. Leave a 1 on the top. With multiplication and division, that invisible math, there's a 1 there. With addition, subtraction, invisible math, the 0 you don't see. All right, so we've got 1/4 x plus 2 over 4 is 1/2 equals 4 divided by 4. Again, that's 1y. We don't see that y. It's invisible. All right, so we're looking for this or anything that's equivalent to that. And I see that right up at the top. All right, question number 8. Which of the statements is true about the rational function y equals -1 over x squared? All right, so as x gets bigger and bigger and bigger, this fraction is going to get smaller and smaller and smaller. If we start with x equals 1, we have -1 over 1. Let's take a look at the graph and see what I mean. Let me go into Desmos. I thought I had it up here, but I don't. All right, so let me open up Desmos. Y equals -1 over x squared. y equals negative. I'm going to put this in parentheses. 1 over x squared. All right, now think about what our answer choices are. Let's go back to the PowerPoint. So we're going to start with x. As x gets bigger and bigger, what happens to y? Both going in the positive and in the negative direction. Always start with your x, even if the y comes first. All right, so let's look both in the positive and negative direction. So let's start with the positive first. Okay, we start at 0. As x is getting bigger, x starts at negative infinity and it approaches 0. I can zoom in on this and see that that line, it looks like it's touching the x-axis, but it actually never touches. No matter how far out you go, it's never going to touch that x-axis. You can drag along that graph, the green line, and you can go out to 1,000,000, 10 billion, a quadrillion, and it's just going to get smaller. The y value will get smaller and smaller and smaller, but it will never hit 0. So y is going to be approaching 0 on the right hand side as x gets bigger and bigger. And then let's go to the left hand side, and it's going to be doing the same thing. It's going to start out, let me zoom out again. It's going to start out when x is 0 at negative infinity, and it's going to approach 0. And we can zoom in and see no matter where we are on that line, it's going to get smaller and smaller, but it will never hit 0. So y is approaching 0 in both cases. All right, so as x approaches positive infinity, y is approaching 0. And as x approaches negative infinity, y is approaching 0. So your answer is here. All right, question number 9. Given f of x equals negative 5x minus 4, we want to solve for x when f of x equals negative 2. Now this time I didn't give you a number here. I said f of x, which is our y, let's replace that with y is equal to negative 2. Don't let that trick you. All right, so I'm going to take this negative 2 and I'm going to put it here. So negative 2 is equal to negative 5x minus 4. Now we're solving for x, so we're going to undo all the operations around x starting with minus 4. So we're going to add 4 to both sides, and we're going to simplify. Keep your equal to separate the left and the right hand side. 4 take away 2, or negative 2 plus 4 is positive 2, equal, bring down the negative 5x, and then 4 take away 4 is 0. The last step is to divide by negative 5. So we're going to divide both sides by negative 5. Negative 5 divided by negative 5 is x. X is equal to negative 2/5. Now let's see if we can find that answer, or if we have to interpret that. Maybe it's written as a decimal, but I think I see the answer right here. All right, question number 10. We have a graph. A cafe owner tracks the number of customers during normal business hours. The graph below models the data. Based on the graph, the cafe owner saw a continual, now let's check these out. Is there a continual increase? Does the graph go up between 6 to 8? Let's find that domain, 6 to 8. All right, it looks like in between 6 and 8, I'm just going to draw a rectangle around that. The graph is increasing continually. It's going up. So I think we found our answer here, but let's check the other answers. Is there a continual increase from 12 to 3? So let's go from 12 to 3, and let's draw a rectangle around that. Well, it goes up, but then it goes down. So it's not a continual increase. That's out. Is there a continual decrease from 10 to 12? So I'm going to look at this area right here, and it looks like it's increasing from 10 to 12, not decreasing. So that's out. Is there a continual decrease from 11 to 2? So let's look at here, from here to here. And it looks like it's increasing and then decreasing, going up and then down. So that's out. Okay, so the answer is the first one. You've got to read that graph and interpret what's happening. Question number 11, for the function f of x equals the square root of x plus 9, find f inverse of x. So the steps are to replace f of x with y. So we're going to say y equals the square root of x plus 9. The next step is to switch the x and the y. So we'll have x equals the square root of y plus 9. And then we're going to solve for y. So we want to undo the operations around y. All right, we're going to start with anything. Well, we have to start with, we have to consider this as parentheses, and we have to undo that. To undo the square root, we're going to square both sides. So we'll have x squared is equal to, the square undoes the square root, and the y plus 9 drops out. Okay, and the last step is to subtract 9 from both sides. We cannot combine that constant with a variable term. So we have x squared minus 9 is equal to y. The 9 minus 9 is 0. All right, so here is the inverse. We need to replace y with f inverse x, because that's what we just found. So f inverse x equals x squared minus 9. Let's see if we can find that. It's right here. All right, next question. Question number 12. We want to know the range of this function. So I could go through this algebraically and factor this, and then I could find the vertex. That's a lot of steps. Because you have your calculator, you can graph it and you can find the vertex. I can visually see that. Let's look at what we're trying to find. The range is our y values. So I'm going to look here, and we start at negative 13 and we go up. So y, not x, our values are greater than or equal to negative 13. So that's this one right here. All right, question number 13. We have the graph of f of x equals the square root of x plus 25. Now we want the domain, so we're looking at our x values. Our x values start at negative, it looks like, let me see, 0, 10, 20, that looks like negative 25. And we're going in this direction, so we're getting bigger. So x is greater than or equal to negative 25. And it looks like this choice right here, the way it's written in set notation. Question number 14. The air temperature in Phoenix, Arizona over a 5-hour period is shown below. What is the range? Again, we're looking at a graph and we're interpreting the range. So we're looking at the y values. What is the lowest point? It's between 50 and 60. It's not starting at 0. So let's scratch these two out, eliminate them. Starting at 55, but are we looking at our x or our y values? When we're looking at range, we're looking at the y values, so we're going to scratch this out. So the y values go from from 55, positive 55 to 70. Now I'm showing you this, but you're going to have to write sentences to explain why this is the range of this set of data. Talk about what the range is, that you're looking at the y values. The minimum value y value is 55 and the maximum y value is 70, and we're including those because we have this endpoint colored in. It's not an open circle. All right, question number 15, we want to determine the domain. Again, we're looking at a graph, so we're looking at the x value. So let's cross out these that have the y. Okay, the domain talks about the x, so these are the only two that make sense. So what is the smallest x value? Now these are not numbered, but this could be starting at -2. But I'm thinking that this is -1, and these are in units of 1. Okay, -1 on the left, and on the right it's going 1, 2, 3, 4, 5. We're not stopping here, we're going all the way here. So starts at 0, 1, 2, 3, 4, 5. How far did we go? We went to 6. So from x is going from -1, including, so we have that equal underneath, -1 to 6, including +6. That's our domain. So with the process of elimination, use that in multiple choice. Eliminate those answers where they're giving you the range instead of the domain, and read your question carefully. It will help you answer correctly, and you don't want to go too fast and think you have the correct answer but miss it because you're confusing your x's and y's. All right, determine whether the following graph represents a function. So we're going to use that vertical line test, and let me just go and get a vertical line before I embarrass myself. All right, and draw that vertical line. Let me try it again. All right, that's kind of a vertical line. You get the point. As I move that vertical line from left to right, it's only touching the graph at one point. So this is a function. Well, I need to get my pen back. So this is a function. All right, 17, which set of ordered pairs represents the function? All right, now we have this. We don't have a table. We just have a list of coordinates. So I'm going to look at my x values, 0, -1, 2, and 7. I could put this in a table. I could put it in a chart. I could put it in a mapping, in those mapping bubbles, but I have unique x's. So for each x, I have a unique output, y. In this set, I have 2 mapping to 2 different y's, 0 and 6. So this is out. In the third set, I have 9 mapping to 2 different y values, -9 and 5. And then lastly, I have 0 mapping to 2 different y values, -6 and 3. So these are all out. The only one where there's one unique output for each x value is the first one. You're going to need to explain that. You may need to write it out. All right, question number 18. F of x and g of x are inverse functions if you input g of x into f and get x, or input input f into g and also get x. So we want to determine if these are inverses. You can graph and explain what that looks like, or you can simply do it algebraically. So I'm going to do it algebraically. So we're going to start off by taking function g, and that's 3x minus 5, and we're going to put it in here where we have an x. So we're going to write 3x minus 5 plus 3 wait a minute, I already made a mistake. Let me erase that. We're going to replace the x with, maybe I didn't, maybe I'm just, let me start over completely. All right, so the x is going to be replaced with 3x minus 5. So we've done that here. And then we still have plus 3 over 5. Now let's work on simplifying that. Let's drop our parentheses, add negative 5 to positive 3, and you're going to get 3x minus 2 over 5. Now we can stop right there because when we simplified, we should have gotten x. If we got x, then we would switch and we would put x plus 3 over 5 into g of x simplified, and if we got x when we switch the order, then these would have been inverses. You can also graph and explain how graphing proves that these are not inverses. They are not inverses. Question number 19. Now we can use our graphing calculator to determine whether the functions f of x and g of x are inverses. So we're going to put this into the calculator, into Desmos, and this into Desmos. And then we're going to look at what that looks like. Let me go back over to Desmos. X cubed plus 4. Let's just get rid of those. Y equals x. I need to get my, open this keyboard up, and a to the b x cubed, click down here, plus 4. Okay, I'm going to scroll out a little bit. And then I'm going to graph y equal, you don't see me typing in the equation. Let me get the equation again. Cube root of x minus 2. All right, now I need to get my functions. I need to go down to cube root. Where is it? Let me slow down a little bit. I know it's down here somewhere. Oh, here it is. All right, cube root of x minus 2. All right, now I can see pretty quickly that those, if I put the equation y equals x or x equals y, that line of symmetry is drawn here, and I can see that they don't fold over, but I can click on a point, 0, 4. I should have 4, 0 on my graph on the other side of that red line, and I do not. So I can tell graphically that these are not inverses of each other. So these are not inverses by graphing. All right, how can you tell by graphing if two functions are inverses? The two functions intersect at x equals 1. That's not the definition that we looked at or the examples that we looked at. The two functions reflect over the y-axis. Well, the y-axis is here, so those are not reflecting over the y-axis or over the x-axis. That's out. The two functions are symmetric with respect to the line y equals x. This is what we're looking for. The two functions are mirror images. That's again another way to say reflect over y equals negative x. but we want the reflection over y equals x or x equals y. That's the same thing. All right, thank you for watching. You can email me. Here's my email. But test corrections are due at the end of the day on Friday. Those have to be turned in on paper. If you need a test correction worksheet, ask me. I'll send it to you. I'll also try to put in an electric copy in Google Classroom if I get time. But I should have paper copies in the classroom. But you can always use your own notebook paper. Make sure that you put your name, your class period, and the date. Write the original problem. Show your work or explain what you got wrong and how you got the right answer, and then put the correct answer. All right, thanks for watching.